Hi everyone, welcome to InnovateXstream. So today we have Rick Bullotta with us. Rick is a dynamic force in the world of technology, blending deep industry expertise with hands-on experience across IoT, robotics, AI, digital, and additive manufacturing. He's a sought after mentor, advisor, and investor. He brings a rare 360-degree perspective shaped by his journey through plant operations, sales, product marketing, system integration, and cutting-edge tech development. A recognized authority on the Internet of Things and advanced manufacturing. So Rick was part of Lighthammer and ThingWorx, two companies I admire a lot. And thanks, Rick, for agreeing to attend this podcast.
It's my pleasure to be with you today.
So, Rick, can you tell us a bit about your journey, how it started and led to co-founding of ThingWorx and
So,
Lighthammer?
certainly, like a lot of people, I was a user of this technology for quite some time. So I started out in the manufacturing industry, steel industry, high speed printing and converting, a bunch of different things. I ended up going from being on the end user side over into systems integration. So I worked for a company that did everything from PLCs and panels all the way up to custom MES systems and ERP integration and kind of all things in between. And my career at that time was during the transition from custom solutions, where we're writing code on mini computers and eventually personal computers, to more packaged solutions. When the SCADA companies like Wonderware and Involution and so on were starting to get some traction, the first generation of MES solutions was starting to get traction. And as I went through that journey, it became obvious, both from what I saw as an integrator and as a user, that our customers had difficult challenges with the proliferation of systems on their plant floors. They had, at one consumer goods manufacturer, we inventoried 400 different systems that they had across their global facilities. Well, there was no unified way to access data from that. There was no unified visualization, no easy way to integrate that with other applications. And that kind of led to the idea that became Lighthammer at the time. And to some extent, ThingWorx was a natural evolution of that, with more modern technologies and kind of learnings from what we did at Lighthammer. But as you know, that became SAP. It started out as a Lighthammer, what we call Plant Information Portal. And that was, in essence, the visualization layer. Actually, prior to that, interesting side note, the code name for Lighthammer was Morning Coffee. And the idea was that plant manager and other team could come in, right, and get with their morning coffee, get a quick snapshot of what was going on in their production facilities.
Oh, yeah,
So that was kind of the original vision.
yeah, that was really interesting side bit. And I have spoken with Joe also, Joe Montagna, and he told me that at that time it was a revolutionary product. The people were happy after seeing those plant data in iTicker, and they were really impressed that they were able to see plant data in real time. So
And,
I believe that had a lot of impact on manufacturing ecosystems at that time. But I think I also believe that it was too good for that particular time period. It was too advanced. So, what's your vision on that?
well, I think it was difficult for what we had a couple things that we thought about as we evolved the product. The first thing, of course, was ubiquitous and abstracted access to data. So the data access layer, which I guess sort of part of it is Pico now, but the ability to get at things from SQL databases and
Mhm.
SCADA systems and historians and OPC and all
Mhm.
that stuff. That was an essential foundational piece. Then, of course, the visualization part that's where humans could interact with it. But I think once we started moving, we realized that if we can give information to humans, we can give information to other systems. And again, this was a kind of inflection point where internet technologies, REST APIs, XML, all this, these new technology that we hadn't quite figured out how to apply to our domain turned out to be really quite useful. And then when we started bringing the ERP and process integration into the mix, of course, that got SAP's attention, and clearly having the support of SAP, who's so completely entrenched in manufacturing companies by and large. I would suspect SAP's the market share leader by a very large margin, certainly for the bigger companies. So that helped us with two things. One, get access to customers, but two, we now have this progression of capabilities that if you weren't quite ready to do sophisticated integration, or you weren't quite ready to do sophisticated analytics, or you could basically just implement the pieces that you needed. I don't know if you recall, the third part at the time was also, we had some stuff around quality. So SPC, SQC kind of stuff.
Yeah.
So, the idea was that even if you weren't ready for, full, deeply integrated top to bottom stacks, there was probably something useful in that technology for you. The other thing, that the fact that it was based on internet protocols, I think we don't talk about this enough, but the reason that became very important is it started to allow remote access to data.
Yes.
So, right. So it could be, a subject matter expert in one of your R&D centers could support the team on site. It could be a equipment manufacturer or a customer getting some quality data visibility. That to me was probably undervalued.
Yeah.
But it was really quite important. In fact, it was funny. A lot of the historian vendors said that once we started offering the ability to view data remotely, their historian sales went up too, because it was added value to the audience.
Yeah, actually, I wanted to know, like, after MII, why did you go for ThingWorx? Was that you were able to identify IoT is going to be a big thing and wanted to build around that, or was there any other inspiration?
So there was after I was on part of the SAP MII product management team for a while, and then I moved over to SAP Research, and we had two main things that I was involved in. We had a team in Dresden, led by Uwe Coopers and some other folks that were doing what we call the SAP Future Factory Initiative. So they were very, kind of research oriented, looking very much into what the future technologies, additive manufacturing, indoor location, all kinds of interesting stuff. We had a living lab there with a bunch of industry and academic partners. So that was kind of giving me a chance to get exposed to some kind of leading edge technologies, but also hearing from a pretty diverse ecosystem of folks what they saw as potential future applications. At the same time, another group in SAP Research, led by Thomas Odenwald, was doing something called real world awareness. And the idea there was connecting systems and software to the physical world, and in all types of verticals, right? So we looked at, and manufacturing just happened to be one of those, but now I started getting exposed to more of these kind of classic IoT problems, fleets of medical equipment, public safety, intelligent traffic systems, all kinds of, applications.
Yeah.
That I actually prepared a proposal for SAP to build this. In fact, the name, I still have the presentation, believe it or not. It's called SAP SoftWorks. And the idea was it was going to be an IoT and IIoT platform, evolving and building upon MII and some other things, but that brought us into those other verticals, which more of an IoT play. Unfortunately, it's just, and there was great reception there. it's SAP at the time was not well suited to kind of incubate new products like that. It was just for a variety of reasons. So we parted friends, and I ended up actually, I'm trying to remember. I think I actually went to Wonderware briefly, but then and tried to get Wonderware to implement these ideas. Wasn't a lot of receptivity there. Said, okay, we'll go start a new company. So that's where ThingWorx came from.
Okay. Yeah, that's really exciting to know. Actually, SAP tried something like in IoT, but it didn't work out. It was Leonardo. I think you might have heard of it.
Sure, of course. I remember that.
Yeah.
Yep.
Yeah. So today, what I feel like the manufacturing is not reaching its full potential despite of all technologies in place. So what are the most pressing challenges manufacturers face today,
I
in
mean,
your opinion?
we'll get a bunch of different answers, obviously, from different people, but the one I do hear over and over and over again is how difficult it is to recruit people to work in our factories, to get them trained and up to speed. The kind of the counterpart to that is all the knowledge that's leaving manufacturing companies through retirement and other things. So how do we empower people with technology to make their jobs less boring and mundane and physical, empower them with information so that we'll get the people that are coming into the workforce now grew up with a smartphone permanently attached to them. They're used to being technology users, and if they go to work and it's so low tech, it's going to be uninteresting to them. And then similarly, how do we augment, use AI, use knowledge capture systems, other, the whole breadth of technology we have at our disposal, going back to making the jobs less laborious, less more safe, and more interesting. So that the people side remains the big challenge. And how do we use technology inclusive of things even like robotics? How do we combine all these things together to make it an attractive place to work? The other dynamic, of course, is a lot of nations throughout the world want to start to reshore and grow some of their own manufacturing capabilities that may have left over the past few decades, or
Yeah.
they want to produce things, domestically. Um,
Mm.
so how can technology help equalize some of the cost differentials of labor around the world, or that the cost of environmental compliance around the world? These are all very real things that affect, why people produce things where they do. So those are some of the big ones. I don't think technology is really the challenge anymore. I don't think it has been for a very long time.
Yeah.
Um, the one though that the secondary thing that I see more and more, and I'd love to hear your thoughts on this because you live it day to day with customers, is when I started in my career in the mid '80s to early '90s, most manufacturing companies had people on site at each plant site, manufacturing engineers, automation engineers, uh, and over time that shifted to fewer or no people at the plant, maybe some people now at corporate. Those staffs have shrunk. So, they're mostly spending their time project managing outside systems integrators and vendors and things like that. So the question remains, one of the biggest obstacles is the time availability of people at manufacturing companies to support these new initiatives. I think money really isn't the challenge. If you've got something that's got a good ROI, somebody will find the money. It's just they don't have the time and capacity. They're trying to keep things running. They don't have as many people as they used to. It's a real challenge.
Yeah, actually, Rick, you read my mind. I was planning to answer this, but you asked me. The availability of the people can be solved. Like I read on LinkedIn, about whether you were involved or someone else. I don't remember. I read it long back. In US, there is a problem that if you are a convict, then you cannot work in any other state. So due to that, the blue collar jobs are not getting enough workers. So if we include something like remote digital twin sort of thing,
Yep.
which is like a PUBG. People are playing PUBG and many online games. Similarly, if your user is able to control his machine using mobile or a laptop, that would be a game-changing thing. It is happening, but due to the lack of knowledge from the business side and lack of integration also, because people have installed OPC server in 2000s, in mid 2000, and those are not advanced, and most of the system integrator do not have knowledge of full stack. If we go for MI implementation, so the integrator will not know about how to connect OPC server to machine correctly so that it can read as well as write data. So I have worked in many MI projects, but when it comes to writing data to an OPC server, people just give up and say that we are not going to do it. So
Well,
that
that's very real dynamic for sure. And what's funny is, I don't think the technology itself is the obstacle. It's just the knowledge of what's out there and how to apply it.
yeah. So that is the thing. If most of the people are looking for the brand name, manufacturers are going for the brand, but they are what I believe is that they should hire an outside consultant before going for a digital transformation bidding, so that they can analyze the vendors neutrally and give the right feedback. There is too many dynamics. In a sense, politics happens when two or more vendors are working for a client. So those kind of things have to be taken care of to get the full potential of the product or the project.
I totally agree, and it goes back to what were the reasons for starting Lighthammer. The one is legacy. Let's be real. It's legacy is pervasive in our industry. Every one of us has encountered some system that's 25 or 30 years old in the plant that's
Yeah.
running perfectly, but we still need
Mhm.
to connect it and integrate it. When we realized that complexity exists, instead of resisting it, we embraced it and said, all right, let's make
Yeah.
that not
Yeah.
the right. Let's make it easier for people by abstracting those systems. We'll worry about the connectivity. But if you need to read a value from system X versus system Y, you should be able to use the same or a similar API to do that. And that's kind of the problem we tried to solve with Lighthammer and ThingWorx.
Yeah, actually, that's what I like about people like customers are not giving up despite of so much of pressure from companies, and but they are not giving up because the flexibility that it provides. You can read from a CSV file, you can read from a web service, you can read from a legacy database, and you can perform your own logic. So much of flexibility is there, so that's why people are not ready to leave. Whenever we go for a upgrade of SAP MII and try to pitch that whatever like SAP DM or some other product, the people are resistant because they are those products are not that much flexible, and the latency and the first thing, the most the most problematic thing in new products are there is that they they are giving cloud connectivity, and that is not a and that's not what manufacturers want. They want a plant level data to be at least at plant, all the data in at plant at all time, because that is their lifeline. So moving to cloud is a problem. That's what do you think about that?
Well, yeah, well, on that topic, I mean, one of the things that a question for you is my impression was that MII over time, people started to use it more in a kind of a headless fashion, right? Where they would use BLS and the kind
Yeah.
of stuff and the APIs, but build their own user experience on top of it.
Mm.
So you can integrate it. It solved a data transformation and access problem, business logic, all that kind of stuff. But increasingly, people are using it kind of with other front ends. Is that something you're seeing?
I have seen it a few times, but that's also like the system integrators dynamics, we can call that. They do not want to give the everything in the first wave, so
Okay.
they will just do the bare minimum, and then maybe the customer didn't renew it, so that's why they were not able to get the full-fledged. Actually, like you said, I started my own company because of the same reason. The big companies, they do not care about giving value.
Yep.
They will. It's just contract. So even if I pitch some idea to my senior that we should do this with MI, they will say we will do it in the next phase, not in the first phase, and next phase never comes.
But
So
and in terms of that cloud dynamic, I think there's lots of factors there, right?
mhm.
Certainly, availability is probably a very real. It's not that the cloud goes down; it's that networks go down. A lot of these
Yeah.
manufacturing sites and mining sites are in remote locations, but there's also the cost and practical and latency.
Mhm.
Think of the classic example. I'm in a chemical plant, right? Or I'm at a biopharma facility, and I'm using information out of my PLCs and my historians to make real-time decisions. And part of that might be looking at, a trend of data for the last 8 hours for a bunch of data points and things like that. Architecturally, it doesn't make a lot of sense to go do a large query. You got to go up to the cloud. All that data
Yeah.
historian goes to the cloud, goes all the way back to the user interface. That just seems inefficient to
Y-
me.
Yes, exactly.
And
Like it's a playbook. Like recently wrote a LinkedIn post. It's about obsolescence. That what 1930s, the all the vendors, light bulb vendors colluded to say that we are going to make light bulb less efficient so that customer keep on buying them. So that's what cloud is. That if you are in cloud, basically you are logged in the ecosystem, and just like Apple. If you want Apple, if you want something from your phone to laptop seamlessly, you have to buy a MacBook Pro if you have an iPhone. Similarly
so
with the Apple Watch also.
I talk a lot about the concept of and not or. And it seems too often that when it comes to technologies or standards or anything in our world, people tend to be very binary. It can only be one. Well, that's not the case. In our world, you know, it's not one or the other, it's and. We have to use a variety of different approaches and technologies to get the job done. And to that end, cloud plays an extremely important role for some of the work we might want to do. For example, cross-site visibility or sharing information up and down our supply chain. That's a very
Yeah.
natural place to put that information to share. Increasingly, if we're doing like training, heavy lifting required and compute required to train AI
Yes.
models,
Yes. Exactly. It should
we
be an
might,
option, but not the law. You should not be locked to it.
yeah. Exactly. And, there are lower risk applications that certainly, with the right survivability models where you can queue stuff locally, certainly some MES use cases that are perfectly valid for cloud. But you just have to, as long as you've adequately planned for all the things that could go wrong.
Yeah. Yeah. Exactly. So, like we are talking about AI and stuff. I just wanted to, it's off track a bit, but I wanted to understand your opinion that AI, how it is feasible in manufacturing systems. So many companies are saying that we are having 35,000 customers' data, so your process will be very efficient. So suppose if a company A is asking the AI assistant, and that how can I improve my efficiency? And AI assistant gives an answer that the answer is that use the strategy that company B is using. So without revealing the company name, it just revealed the whole process of company B. So won't there be a conflict of interest
Yeah, I think it's very
there?
difficult for a variety of reasons. I don't think it's always, I mean, when you're talking about it depends whose perspective you're looking at it from. If I'm an equipment manufacturer, so let's imagine I sell a piece of case packing equipment that goes into food and beverage facilities. In that scenario, I might want to be using data across the boundaries of lots of different customers to help train my models to make sure my piece of equipment is, running optimally in all those customer use cases. So that's kind of an example where you can see information sharing across the boundaries makes sense. When it comes to but when it comes to things that are proprietary to my business, and leads to another discussion, which is a lot of folks have focused on applying AI to the assets, not enough to the processes, because that's actually where I think more value will be unlocked. Of course, we want to keep the assets running and running optimally, but it's how a group of assets and people operate together that determines the real economic output of that equipment and that process. So I think the
Yeah.
processes are obviously so unique to one site, one line, maybe even one product, that it becomes it doesn't mean you don't use cloud for training them. You don't necessarily mix data across many customers. Now that happens more with assets, like trying to determine how pumps behave, or pieces
Mhm.
of electric motors, drive systems behave, or whatever. It is helpful to look across a broad population. A lot of those asset-centric AI companies do that.
Yeah, but are companies really taking giving that discretion if they have the data? I don't think they are running supervised model when suppose ChatGPT or Grok 3, they are not using it supervised model that what to train on, what not to train on. So in that case, it might be a problem. That's another discussion that we can go into.
I
Uh,
To be honest with you, I don't think that a lot of the work thus far has really been around, and for a variety of reasons. I don't think LLMs, SLMs, all that stuff is there's certain characteristics of, particularly when you get into like the deep analytics and closed loop optimization, they can help, but we're more back in the world of traditional machine learning, right? As opposed to large language models. Now, can LLMs help us do things to be more effective with machine learning? Absolutely. There's so many tasks that are kind of grunt work to prepare
yeah.
data, to prepare, to kick off training models, to interpret it, to visualize it, to operationalize it. Yes, we can use, agentic AI and LLMs and all that stuff as a key part of it. But still, like companies I work with, at their core, it's still a lot of like other kinds of classic AI, right? Machine learning, vision models, things like
Yeah.
that are unlocking
Okay.
the real value. The other thing that's happening now is more and more companies are like, one of the companies I work with is TwinThread. They're getting to the point where they're closing the loop and optimizing, product characteristics and energy usage completely in a closed loop, all the way down to the control systems. So
Oh,
we've gone from an evolution to just be kind of recommend something and give advice to the operators, to the point where now the machine learning models have developed deep underlying knowledge of the dynamics of that process and are able to optimize it. And that can never be done in a you know in a um, you can't take a model from one site and give it to another customer who makes a completely different product on different equipment. It would just never work.
oh. Yeah, yeah, I understand. It's all about perspective. A gun in the hand of a soldier will protect us, whereas in the hand of a criminal, it will be harmful for us.
Yeah.
Let's get back to the podcast. We got distracted, I think. What are the critical elements to consider when designing a modular, scalable industrial platform? You have designed and you are supporting many companies. So, is there a key thing that you want to share with us?
A few. I mean, ultimately, they all come around the umbrella of extensibility, which is something I've always designed, deeply
Yeah.
into all I've built. So you ought to be able to. And what I found over the years is that building extensibility into the architecture yes, of course, it helps partners and customers, but it also helps your internal team be able to deliver things more quickly because you've modularized, you've isolated, you've built software development kits and APIs that allow things to evolve, more loosely coupled. But just as importantly, it allows your ecosystem to build additions to your platform that are very unique, and that starts from the connectivity layer to the business logic layer to data models to visualization components. All of those things need to be extensible, and so I've always kind of taken that API first, extensibility first mindset to building things.
Okay, okay, yeah. Yeah, that sounds logical. So, how would you recommend balancing real-time data needs with long-term data governance for manufacturer, like cloud and like we were talking just now, they should keep the cloud data and how the real-time data should be handled.
Yeah, I mean,
I have heard about a concept called inverse historian. So, should we keep all the data in a historian or data lake, or what's your opinion about it?
it's very industry specific and use case specific how much data you need to support real time operations. I mean, if you're doing a biotech process that takes 30 days, you should probably have at least that 30 days on site, so there's no surprises. You can keep running. You can do your near real time analytics. Some people have compliance reporting requirements where they need to retain data for 7 years. It doesn't need to be, it could be in cold storage, like in the cloud or in a data center or something like that. It doesn't necessarily need to be in the historian. So, it sort of depends on the use case. Similarly, a lot of people in some of the process industries, the historian is the center of the universe. It's often used even as the kind of latest values perspective for supporting operations. So its role definitely varies, but ultimately it's some amount of local storage that you're going to use for real-time operation support and for that's guaranteed to be available even if the external network's down. And then based on your needs for sharing information, archiving information for compliance reporting, that'll determine where you long-term archive that. That said, I do, you're having your primary historian in the cloud. I know some people are trying to go there. It just doesn't make a lot of sense to me. I think that, and I've run some calculations, on what the relative cost could be. Even with
Yeah,
it can add up very, very quickly. It's so
yes.
specific to the pricing model of the cloud stores, but in any case, I think we're kind of that's okay. Actually, let's back up 1 second. For industrial IoT use cases like factories and utilities, I think on-prem historians are going to play a role for a long time. In the IoT world, of course, it's the complete opposite. You're cloud first to begin with. You've got a fleet of geo-distributed assets. You're connecting to them from the cloud. Therefore, the data will reside in the cloud as well. So it is kind of use case specific, but for factory and utility use cases, I think it's still going to be a lot of on-site data, even if it's
Yeah.
just a few months or a few weeks or a few months.
Okay. Yeah, actually, this OPC UA can be handled easily, but the real pain for any system integrator with MI or ThingWorx or DMC, anywhere where there is a connectivity is DA. OPC DA is very painful and still very many customers are using that. So I have heard about like a connector which converts DA into UA. But shouldn't that say OPC DA be retired and free upgrade to provided by the vendors at this stage so late in the game?
Well, it'd be great if everything just spoke some standard protocol, right out of the box. But in my experience, that never really materialized. Adoption is much lower than I think the world perceives of a lot of these standards. And even there's enough flexibility and complexity within some of these standards that the implementations are not very uniform, not always interoperable, things like that. In theory, they should be. In practice, they actually tend not to be. So, they're helpful. They're all helpful tools. And as we discussed earlier, legacy is going to be around for a long time.
Yeah.
But there is no magic, right? There's just no magic thing that will solve all these problems for us. I just think, ultimately they're all helpful technologies. But there's a reason that the Kepwares and Litmus and Softings and these Matricon, that they all
Yeah.
still do quite well, because there's so many devices and systems that just, even the ones that support OPC, UA, and DA, and HDA and all that stuff, it's still sometimes better to go. For a variety of reasons, you still need to speak the native protocol. Something does, eventually. Now, there are obviously newer PLCs and some other systems that are capable of OPC UA natively. But even then, that's not always used.
Yeah. Yeah. Actually, I brought up this question because we are preparing something, and the challenge here is DA, because there is no support for DA apart from .NET, Microsoft .NET. So there is where we are getting stuck. We wanted everything to be within product, but
Sure.
that DA is not working out. So,
Well, the
yeah,
good news moving forward, with OPC UA, and .NET Core now being true multi-platform, we've at least broken away from, and there are a number of SDKs in the OPC UA world that aren't .NET based, but even in the .NET world, our ability to deploy on Linux devices and Windows devices and other devices is increasingly feasible. I think part of the challenge, at least that I've seen with the all this alphabet soup of MQTT, OPC, UA, UNS, this, that, the other thing, they're still largely divergent approaches. There's not a lot of consistency between them. And this is where, the software platforms build that abstraction. But ironically, when you build that abstraction, you've sort of created yet another meta stand, and not a standard, but you've had to come up with a new data format that's sort of the that you can express all these other data formats inside it.
yeah, yeah.
Just as
So
how
yeah, it will keep on getting complex, like a Russian doll or Chinese doll. I don't remember. A doll inside a doll.
there is,
That's all.
there are some folks, doing work to cross those boundaries, right? To see better interop between all of these different approaches to the problem. Um, but it's there's humans involved, and as long as to get humans to agree, someone wins and someone loses, right? And if
Yeah,
my approach becomes a standard and yours doesn't, well, you know, it's just there's
yeah, yeah.
human.
It's all dynamics. How you play your cards, that matters actually.
The other problem that happens is inevitably you get enough people in a committee or a room, you end up with the lowest.
Yeah,
The thing they can agree on is the lowest common denominator. Well, the important word there is lowest, right? I mean,
mhm,
it's so
yeah.
it kind of dilutes the value.
Yes, exactly. So, for for diverse user requirements regarding manufacturing from top floors to top management, what are the strategies do you suggest for someone creating a platform?
Yeah, in terms of what being able to, could you repeat that question?
Yeah, what strategies do you suggest for creating platforms that can adapt to diverse user requirements from shop floor workers to top management? You have done that with MII and ThingWorx, but
Right.
at present, technology stacks that is available, what do you suggest?
And again, I don't even think it comes down to specific technologies per se, but rather architectural approaches. As we discussed earlier, having, APIs to everything. I think that's absolutely every part of your platform, your product should be, data and functionality should be open and accessible. I'm a big believer also that even the design elements, like the things that you can do through the IDE or the development tools that a vendor provides, you should have an API for those as well, so that systems integrators, other partners can kind of automate the configuration of the system where it's feasible. And
Yeah,
in terms of integrating upwards to the needs of upper management, whether that's process integration with your ERP, whether that's aggregate KPI views, whether that's kind of exception reporting. Those are all still come back to the fact that you need open and easy access to that information and capability. And I also believe that any modern architecture needs to be event driven. It's just sort of that's kind of the only, and time is an example of an event. Every 10 seconds is just a special kind of event. But architecting around event driven models is important.
okay. Thanks a lot. And if you had to envision manufacturing landscape 10 years from now, so what would it look like?
Huh, that's a good question. Well, we'll all be working from home. The robots will be doing all the work, and I'm kidding, of course, but but we I think we're going to see more of the drudgery work be automated, continued investments in automation and information. I think we're going to see fundamental change. We're already seeing it, but fundamental changes to like what a manufacturing company is. I mean, if you look at something like someone like an Apple, how complex, they have people that they contract to develop products, even design. They have contract designers in addition to their own. They have contract manufacturers, food companies now, and pharma companies that are basically becoming the brand owner, but the actual value network for designing, building, servicing, selling. Those are all becoming kind of disintermediated. Not everywhere. So the whole rethinking what the value network looks like is going to be fundamentally different. AI is going to be ubiquitous. It's just going to be a feature. It's not. It's just going to help us do our jobs collectively better, whether that's an engineer configuring a system or whether that's an operator running a process or a system. That it's going to be pervasive, just like mobile phones are in our hands today.
Yeah.
It's just going to be we just won't even think about it. It's just going to be part of it. I do think robotics is going to play a role, but broadly mechatronics. So this fixation with humanoid robotics, I'm not a big fan. I don't think they're
Yeah.
optimal for a lot of use cases. There are some, but we will see a kind of new wave of mechatronic and robotic systems that you train fundamentally differently. They could literally watch someone do a task and then learn it, or they're more adaptable to new tasks as opposed to the way we tend to train program robots like we program CNC machines, right? Repetitive movements and some basic ability to adapt to the unpredictable. But that's changing dramatically with AI and machine
Yeah.
vision. So that's going to be different. The workforce is going to be very different. I have a feeling. I hope it's better paid, higher skilled. But yeah, it's going to be. That said, all the systems that we have today will probably still be running. And just as we talked about the legacy stuff that we deal with that's 20 years old, the stuff that we implement today will be those legacy things 10 years from now as we have.
Yeah. Yeah. So that brings to the end of our episode. So last question that I want to ask you is, what's one piece of wisdom that has guided you throughout your journey?
That's a good one. Focus on your customer. If you focus on doing what's best for your customer and helping them be successful, everything else takes care of itself.
Yeah, that's a really good. Actually, I'm really happy to that you said that, because I also believe that providing value to the customer is the thing where we can shine on. Uh, so
And
that
it
brings to, yeah.
and it creates, it creates a loyalty relationship where, you're gonna get to, like, as a supplier of whatever services, technology, you develop trust. And honestly, it's better from a business perspective. You're going to be able to do more work with that customer. And it's just fundamentally, it's the right thing to do.
Yes, yes, exactly. So, Rick, thanks a lot for agreeing to attend this podcast, and it really helped us, and it inspired me to talk with you. And I hope you will be able to get some time later also when we'll be talking about more advanced technologies or more advanced concepts. We are
I
not
look,
yet sure.
I certainly look forward to it. It was a pleasure speaking with you today.
Yeah, thanks a lot. Rick.